going mass to mass. Okay, I call these a loop-de-loop problem for the way that we travel on the mole map. Okay, please have your mole map handy because we are going to write a couple more things down. But I'm going to give you another format of the same way that you're going to set up the problem, so that if you don't like the mole map way, you could do the other way and it'll still work. Okay, just like with moles, we could do the same thing with mass. But this time, instead of having just 2 parentheses for our solving, we're going to have 4 parentheses for our solving. Okay, so it's going to be a lot. That's why there's only 4 today. Okay, so in order to convert between the masses and the reaction, we have to use the molar mass as well as the coefficients. And it's super important which molar mass you use where, because if you put the wrong molar mass in, you're going to get the wrong answer. Okay, so did everybody write down molar mass so we can move on? Okay. So these are the steps that we go through. I'll have you guys write these stuff, fill in the stuff right now, and then we'll look at the mole map and write some stuff in. Okay. So the step one, the pre-step is you put the answer or the number you're given over 1, just like always. Okay. And then the next step, you go from the mass circle to the mole circle. So you're using the molar mass to get there. Okay. But it's the molar mass of the given. So we're going to write that down on our mole map in a second. Then, after you get to the mole ratio circle, not just the mole circle, you're going to use the mole ratio like we used yesterday, where you put the coefficient of the want over the coefficient of the have. Okay? And then the last step is you're going back to the mass circle to use the molar mass. But this time it's the molar mass of the thing you want to know about, or the wanted substance. Okay? So, looking at our mole map quickly, we're doing this today. Okay? So don't write this down on your thing because it's not going to happen every day. But we're starting in the mass circle. We're going to go up to the mole ratio, and then after the mole ratio, we're going to go back to mass. Okay? So I call it a loop-to-loop problem because you're just like looping around, right? So when we start in the mass circle, this is our mass over 1. Okay? Just like we've done any number given over 1. The 1 mole over molar mass take up to the mole ratio is a specific molar mass. Okay? So on here, I would write down that it's the molar mass of your given molar mass, or known, or something like that. So it's going to be like 1 mole of the known over the molar mass of the known. So molar mass, remember, is like if it's H2O, you have to take like the 1.008 from your periodic table times 2 plus the 15.999. Does everybody remember that stuff? Maybe, hopefully, after 5 minutes it will kick in. But then, so the molar mass of the given, this will be a given step. Then we'll have our moles want over moles have, just like we did yesterday, moles question mark over the moles given. And then the last step will be the molar mass over 1 mole. This time, the molar mass is going to be of what you want. Okay, so this will be the wanted step. Okay, so it's going to be different than the first molar mass. You're not going to plug the same 2 numbers in because you won't get the right answer. They'll just cancel each other out, and it doesn't work that way. Okay, so the way that this is set up, you're going to have 4 parentheses across. So I'm going to erase this and go back just so you can see what the 4 parentheses will kind of look like. Okay, so the first parenthesis, and you can write this down, you don't have to, I'm just talking it through. So some people like seeing it this way better than the mole map way, and that's fine. You're going to have your number given, and it's going to be in grams, over 1. The 1 doesn't have a unit. It's just like how we always start out our dimensional analysis, okay? And then the next step is our 1 mole over molar mass. So it's going to be 1 mole of the have substance. I'm going to just put have because it's what we know about, okay? And then I'm going to put MM stands for molar mass. So this will be the molar mass of what we have. Whatever was here, that's going to be the molar mass down here, okay? So that the grams can cancel away. Then the third parenthesis is going to be the mole ratio. So MR stands for mole ratio, okay? Where it's the moles want over moles have. And this is the only place where the coefficients come into play. Everywhere else, the coefficients should not be there, okay? And then the last step will be another molar mass step, but this time it's going to be the molar mass of the wanted, the molar mass of the want over 1 mole of the want. Because the way that you solve this, the unit that's left over on the top, most right parentheses, is going to be the unit for your whole problem at the end when you solve. Okay? So that's how the units should cancel in order to get there. So if you want to, every time we're going to have a balanced equation for each problem, and then we're also going to have 4 parentheses across for each problem. Okay? It's a lot. That's why there's only 4 on the worksheet. Okay? So I do have 2 examples. We'll see how we feel after the first one. If you guys think you don't need to, then we'll just stop. Okay? Here we go. So, calculate the mass of ammonia gas produced by the reaction of 5.40 grams of hydrogen gas with an excess of nitrogen gas. To save us some time, this equation was used not a million times, but a lot of times yesterday. The equation that we used in example number 1, I think, on the other side, on page 2, was that N2 plus 3H2 yields 2NH3. We're going to just save some time and just write that down right now, okay? Because the nitrogen gas reacts with the hydrogen gas to form the ammonia, which is NH3. And it's already balanced because we used it a bunch to already balance yesterday. So we're just going to not take that time right now. Okay. Now, let's figure out, yesterday I did the whole, like, put the question mark under this part and then put the number under this part and cancel it out. Did I do that yesterday? Okay, first hour is just my bad hour. I didn't teach it that way. Okay, so what are we trying to find here? What's the question asking for? The ammonia gas, and we want to know the grams of the ammonia gas because it's mass, and we know that mass is grams. So I'm going to go ahead and put question mark with a G, so I know that my unit is going to be grams. Okay. And then I have 5.40 grams of hydrogen gas. So I'm going to go ahead and put my 5.40 underneath the hydrogen. So that means, do I need H2 anymore? No. So I'm going to cross it off just so I don't look at it anymore for this problem. Okay. Now we get to set up our 4 parentheses. And we're going to set them all the way up and then we're going to solve at the end. Okay? We're not going to stop and solve after we write each one down. So the first step is putting the number we know over 1. So we know 5.40 grams, and it's grams of hydrogen gas, so it's grams of H2 over 1. Remember, the 3 doesn't come into play yet. The 3 only comes in at the mole ratio. Okay? So now, I can't switch back to the mole map, otherwise it'll erase. But we're in the mass circle, and we're going up to the mole ratio circle. So we have 1 mole over molar mass of the have or the given or the known stuff. Okay? Well, what we know, the known substance, is whatever's right here. So we know about H2 right now. Okay? So on top, it's going to be 1 mole of H2. And on the bottom, we need to find and put the molar mass of H2. So I'm going to go ahead and fill in my GH2. Molar mass. This is where we got to look at our periodic tables. Okay? I'm going to show the work just so we get our minds refreshed on how to do this for now. So for molar mass, we look up the mass number from the periodic table, and then we multiply by subscripts. So what's the number for hydrogen? 1.008. Okay? And then, since there's a 2, because it's a honkel fiber diatomic, that means we're going to multiply it by 2. Okay? Do I multiply by the 3? No, because the 3 is not included yet. So we don't worry about the 3, we just worry about the subscripts, 2. Okay, so that times 2 is what? .016, yeah. Okay, so that 2.016 is going to go down low. Okay, so then we can cancel out our grams of H2. Halfway. Next, we are now in the mole ratio circle. So it's 1 over half. So question mark over what we've been dealing with already. So we want to know about the ammonia. So it's going to be 2 over 3. Right. So 2 moles of NH3 over 3 moles of H2. Anybody confused about where that came from? Because we had to put the H2 on the bottom so that we could cancel the H2s away. So now we're dealing with the wanted stuff. Okay? So then our last step is going back to the mass circle on the mole map where it says molar mass over 1 mole of what we want to find about. So we want to know about the NH3, so we're going to have to put the molar mass of the NH3 on the top. And on the bottom, just so it cancels, I'm going to put 1 mole NH3. Okay? So we need to look up what N is, and we need to look up, we already know hydrogen. So for the NH3, what's nitrogen's number? 14.007 plus 3 times, yeah. And I'm out of room, so my answer for this is just going to be plugged in right on the top line. So what do we get for a molar mass? 0.031. Okay. Grams of NH3. Okay. And I ran out of room. But that's okay. So then our moles of NH3 are done. So now it's time to solve. Okay. There's 2 ways of solving this. Alright. What I like to do is I type in my first number and then I just go each parenthesis. So if it's the number's on top, I multiply. If it's on bottom, I divide. And you just work your way through. Or you could multiply across the top and get a number. Multiply across the bottom and get a number. And then with those 2 numbers, divide them at the end. Okay? So do what works best for you, and we'll see what we get. $17.9125. That doesn't sound familiar. Did you multiply by 2 on top? That's... Good thing we're doing this first thing in the morning. Gray screen of death is not good this early in the morning. I'm going to show off the rest. Okay. Give me 1 sec. Better not. So the final answer should be 30.4. Okay. Grams of NH3. Alright. So that's it. How do you guys feel? Do we need to do example 4 or do you feel okay? Feeling okay?